Okay, here's my little exploration of Buffon's needle. What I've got is 500 needles that have been dropped onto the surface. I'm simulating it, and some blue lines that are 2 apart. So we can see that these blue lines are 2 apart. Each of the length of the needles is of length 1. I've counted how many of the needles cross the blue lines, and you can see they're coloured red, and we've got 158 out of 500. And then I've done 500 divided by 158. to get a total of 3.1, to get a number 3.165. I'm going to repeat this simulation, and I'm going to keep a running average, so I got 145 this time, and I'm repeating it loads of times, and if you look at the number down here, you might be slightly suspicious about what this number looks a bit like. And indeed, if we did it forever, this number is actually going to, although it looks like it's going away, it's actually going to approach pi. Give it on a bit longer. You can see it's coming down. And it will actually approach pi. Okay, so why is that? Well, here's the I've rotated everything 90 degrees, and here's 3 situations. I'm going to let the distance from the center to the nearest line, you can see we must be over this purple line, otherwise we'd be nearer the top one at the top. So again, I'm showing that this is what 2 is. I'm going to let the distance from the centre to the nearest line be d. And since these are of length 1, I'm going to say this is half from the centre to the end. And I'm interested, does the end of this cross the line? Well, we can see if we draw a right angle triangle, and I make this theta, this is going to be a half cos theta. And so since here d is greater than a half cos theta, this does not cross. In this one, it is equal. So we have d is equal to a half cos theta. And here we can see that it does cross, and I've coloured it red. And so we've got d is less than a half cos theta. Which led me to think, well, couldn't I draw a graph of d against theta? And each point is going to represent how far away it is and what angle it is at. And here is my simulation of that. I can see that I can move the point around, and as I rotate, if I move it left and right, it's rotating, and I move it up and down, and you can see that it turns red if I'm getting closer, and there. And so what I'm interested in what points on the graph on the left are the points where the graph, the line does actually, the needle crosses the line. And with a bit of thought, you will see that it's when d is less than a half cos theta. And so I've sketched a half cos theta here. Here's theta, this is d, and you can see that that is the points at which it will cross. It's when it's under there. So let me show you that one here. So these points we can see it's crossing, but if I go up here, it doesn't cross. Of course, I can move it out of this region, and so overall I can see that this is what it would look like. Actually, this is the picture, this is when it crosses, and it crosses here, and you can down here, and I'll let you play around with this, and I'll put a link to this file. But of course, I can just restrict it to this bit, because everything else is just a repetition of that. And actually even further, I can just restrict it to that, because the rest of the plane is just a repetition of this. So, what are those areas? Well, it's a half cos theta. And so you can see that the rectangle is pi wide, and it's 1 high. So the area of the rectangle is equal to pi. The area of this region, r, I can see that r is equal to the integral from minus pi over 2 to pi over 2 of a half cos theta d theta, and that is equal to 1. So overall, we get that the blue region is pi, and the other region is 1, giving us the prediction of the area, prediction of this count. And so I'm going to run the simulation And we can see it will eventually approach pi.